Okay, lesson 29, the objective was connect division by unit fraction to division by 1/10 and 1/100. Now, the first part of your homework basically was trying to show you how you can divide it by place value and think of it as unit form. And we do that, we can see here we have 9 divided by 1/10. And we know that there are, as example up here shows, there are 10 tenths in one whole. So if there's 10 tenths in one whole, that means 9 wholes, there would be 90 tenths. And over here, if there were 10 tenths in one whole, that was 6 wholes, there would be 60 tenths. Okay, when we come over to D, we're talking about tenths again, and we can see, and I like doing like this also, if there's 12 wholes, and I'm talking about tenths, I can tell there's 120 tenths in 12 wholes. And then there's going to be 8 tenths and 8 tenths, gives you 128 tenths. Now, if you get confused on how many hundredths are in a whole, I always like writing out the decimal. Then I can place it underneath, and it wants to know how many hundredths in one whole. So if I put 1 and 0 zeros in my hundredths, I know there's 100 hundredths in one whole. That means there would be 300 hundredths in 3 wholes. On F, we know once again there's 100 hundredths in one whole, so there'd be 7 hundredths in 7 wholes. Now we're going to break it down by place value again. Once again, we know there's 400 hundredths in 4 wholes, and there would be, we're talking about tenths, there's 7 tenths, but it would be 70 hundredths, which gives us 470 hundredths in 4 and 7 tenths. Now 11, if you can tell here, there would be 1100 hundredths in 11 wholes, and there would be 30 hundredths in 3 tenths. So we would end up with 1130 hundredths in 11 and 3 tenths. And you can do this by, and we're talking about hundredths, you read the whole number of 1,130 hundredths. Okay, now we're going to use what we used in the past, skills, in order to solve these problems. Now the first thing I like to do is rewrite any division problem as a fraction, so we end up with 2 over 1/10. So now I have 2 over 1/10, and I'm going to create an equivalent fraction that is going to get rid of this decimal. And I know that if I multiply by 10, it's going to shift one place value. But since I'm creating an equivalent fraction, I'm going to have to multiply the top by the same number. And 2 times 10 is 20. 1/10 times 10 is 1, so we know the answer is 20. Now, 2/3 divided by 1/10. Once again, rewrite it as a fraction. So now we have 23 over 1/10. And I'm going to move 1 decimal place. So I know I'm going to multiply by 10. And that's going to give us 230 over 1, which equals 230. Okay, now I'm going to rewrite it as a fraction, 5 over 100ths. This time, I can see I need to shift 2 place values. So in order to do that, I have to multiply by 100. So now I end up with 500 over 1, which equals 500. Now we have 7 and 2/10 divided by 0 and 1/10. Now when I have decimals in both numerator and denominator, we're looking to see which one has the most place values we have to get rid of. In this case, they both have just 1 place value we need to move. So we know we multiplying by 10 will get rid of the place values on both of them. And we're going to end up with 72 over 1, which equals 72. On E, I'm going to rewrite it as 51 over 0 and 100ths, which I can see this time I'm going to have to multiply by 100 on both of them, and I will end up with 5100 over 1, which equals 5100. On this one, I have 31 over 1/10. I can see I'll need to multiply by 10. So I'll end up with 310 over 1, which equals 310. On G, I have 231 over 1/10. So we're going to shift one place value, so we know that's 10. Now I have 2,310 over 1, which equals 2,310. Now we have 4 37/100 over 100. Now even though both of them have decimals, I can see they both need to move over two place values. So we're going to multiply top and bottom by 100. And it's going to shift two place values. So I end up 437 over 1, which equals 437. Under I have 24 5/10 over 100. Now I can see I need to shift this one two place values. I only need to shift this one 1, but since I need to shift two place values, I want to multiply top and bottom by 100 because it has to be an equivalent fraction. So when I shift this decimal 1 2 place values, I end up 2,450 over 1, which equals 2,450. Number 4. Geraldine solved the problem 68 divided by 100 equals 6,850. Ralph said this is wrong because a quotient can't be greater than a whole when you start with. For example, 8 divided by 2 equals 4, 250 divided by 5 equals 50. Who is correct? Well, the easiest way to show this is I'm going to use their example of 8. 8 divided by 1 is going to give us 8. Now, this rear disproves this right here. You can't be greater than a whole number. Well, it's not greater. This one here is equal to. So if I go 8 divided by 2, I know this is going to be 4. So far, what Ralph said is correct. But when we come down here and go 8 divided by, let's say, 1/2, we know 8 divided by 1/2 is equal to 16. So our quotient ended up being greater than this. And that's because Ralph is wrong because he is only talking about dividing by whole numbers greater than 1. If you divide by a decimal, you're going to end up with a larger number than your dividend. Price for an ounce of gold on September 23rd, 2013 was $1,326.40. A group of 10 friends decide to equally share the cost of 1 ounce of gold. How much money will each friend have to pay? Well, to keep it understanding what I'm doing, I know here's my tape diagram, and I know this is $1,326.40, and we're dividing this up between 10 friends. And we want to know how much each one is going to have to pay for. So we know this is $1,326.40 divided by 10 people. Well, to do this the way we've done it in the past, okay, we could do this a couple different ways. First thing, for dividing by 10 for this problem, we know it's going to get smaller because I'm dividing by a whole number, and I'm shifting decimal point one position to the left. So we can see that 10 people would get $132.64 each. Now that's by understanding the place value system and dividing by 10. Now let's see if we did it the way that we've been doing it in class for this lesson. If I have 1,326.4 divided by 10, I know that if I want to multiply this by 10, I would get 13,264 divided by 100. Now, if we broke this down, we know this would be 1,364 times 100, and under here would be 100. So we cross these out, we end up with the exact same. So in this scenario, it would be more efficient to use our old standard.